is coming back. It's going to be coming up throughout this unit. So if you pay attention, if you kind of just try to understand the concept, you're going to have an easier time when it's time to actually do math, right? When I'm asking you to actually come up with the probabilities. So in a nutshell, for the most part, there are two different types of probabilities that we will encounter. Theoretical is what should be happening, and that's usually with card games, dice, spinners, ducks at a fair, right? There's like all yellow except for one is red, and if you get that one, right? Like, so that's theoretical. And then experimental is what actually happened. It's based on data you collected. So you could be tossing a coin, you could be rolling die or dice, and so you be actually be collecting information as you go. And these two do not always coincide. They're not always the same. They should be, especially when it comes to cards and die and stuff like that, or tossing a coin, they should be very similar. If they're not, then there's a problem with the sample size or the number of trials you've performed, right? So if it's a small sample size, then usually they are not the same. But when you increase the number of trials, notice the wording I'm using over and over. If you extend or increase your number of trials, or you ask more people about their opinion, then they tend to be very similar. Okay. Obviously, it's not always the case. Like you can't, for example, let's say there's 3 people running for president or prime minister, right? It's not 1/3. There is one candidate that's preferred over the other. So not always is that the case, but for games or anything like that that's random, where there's no bias, it should be the case. Okay. Let me give you a very, very quick example. You don't need to write this down. Just watch here, right? So let's say somebody's doing an experiment, right? And somebody's tossing a coin 100 times, and then you record your findings, right? So you got 70 out of the 100 tosses landed on heads and 30 landed on tails, right? So then the tables are very, very popular in this unit, so be ready for it. So if I ask you, what's the experimental probability of the coin landing on heads, for example? If it's saying the experimental probability, you got to go back to what actually happened. And in this case, it would be 70 out of the total, which is 100, right? And that is 70%. So that's what actually happened. And then if it then asked you, right, what's the theoretical probability of the coin landing on heads? What is it? You all know this one. You've learned that since, I don't know when probability was first introduced, probably grade 5. But that is 50%, right? You would say that when you toss a coin, there's a 50-50 chance of it landing. So you're like, what? Why are they not the same? You would have to say that whoever performed this experiment would have to toss it 1,500 times or 2,000 times, like increase it. Then you will start seeing them getting closer and closer together. Perhaps not exactly the same, but it's going to be very, very close, right? So that's what we're going to be talking about as we go through the notes. Okay, so let's please follow me now to 145. I want to review that concept down here that we wrote down, right? There is always, if there's a probability of rain, there's a probability of it not raining, right? There's always something that adds up to it that would make it 100%, right? So I give you several examples on 145, right? Rain, if it's 60% chance of rain, then the chances of it not raining automatically would have to be 40 to make it add up to 100. If I told you that the probability of passing this course is 0.65, you recognize it's a decimal. then the probability of not passing is 0.35, right? That adds up to 1. And so forth. We did it with fractions. We did it with winning the lottery. Everything has for or against everything in probability, okay? So let's keep going. On page 147, we ended up on 147 at the bottom there. And I want to make sure that we added this piece. Yeah, I'm going to add a bullet there. But before I get there, actually, this is one that's going to happen quite often. 146. The bottom of 146, you should have written this down at the bottom where you're making a prediction based on your smaller probability on a small scale. You're going to kind of make a prediction as to what would that mean on a larger scale, right? You're projecting, you're making a prediction. And this is how you do it. I would strongly recommend you put that on your study sheet because it's going to happen. So let's, on 147, before I move on to a new example, okay? We talked about this example. They gave us different colors. And we came up with our total that is 50. There were 50 candies in that bag. And so we came up with the various different fractions is the most popular, and then we turn it into a decimal percent if needed. Okay, we made a prediction of getting red candies in a larger setting with 1,000 candies in the bag. We did that. We also made a prediction of how many orange candies would you get. That's on page 147, all right? Then you get 260. This is where I want you to add now on the bottom of 147, okay? Add this, please. So we're going to add an E here because this book doesn't have a lot of examples, but I will throw this at you quite often. I will say this. State the probability. Okay, state the probability of a candy not being green. Not being green. And obviously what the question is saying, like if you were to randomly grab a candy, emphasis on the not, okay? What would be the probability of it not being a green one? And I'm going to do this a little differently here. I will say, hey, let's do this first. Probability of green would be what? How many green candies do I have? If you look up there, we have green, 10, right? 10, yeah? 10 out of 50, right? So probability of not green, do you remember the symbol for not? Put a line on top of the word. Okay? Probability of green is 10 out of 50, so not green must be, how many are not green? 40. 40 out of 50 are not green. So if you were to add these up, green and not green add up to 50 out of 50. So, so this is the answer. This is the one we are asking for. And that's the answer. If you went 40 divided by 50, you get 0.8, or you would get 80%. So this one is actually fairly easy to state in the two different formats. Okay. So green, we didn't want this, but I stated it to make sure we can compare them and see how they would add up to 100%. Rain, not rain. Green, not green. Pass, not pass, right? Good. Next page. I will ask you to write down a question at the top of that one. So we're gonna, so 148 at the top, you have a blank there. I want you to write down the following. I'm just gonna block some stuff here because I don't want you to see the whole thing just yet. Okay, I'm gonna zoom in a little bit. And I will read it to you in case you can't read my writing. So at the top of 148, it says a food truck offers 4 menu items: hot dogs, burgers, chicken fingers, and onion rings. Okay? Those are the 4 options you have. Here are the actual sales, right? So you sold 45 hot dogs, 65 burgers, 70 fries, 40 rings. You can shorten that if you just want to go H, 45, B, 65, and so forth. You can shorten it if you want. And then write down the question. What's the experimental probability of someone buying chicken fingers? I'll leave it up there for a bit. The reason I'm adding is because this book doesn't have a lot of comparisons, not side by side, right? So you want to have this. So go ahead and write that down. Okay. So the experimental probability of someone buying chicken fingers, you would have to say probability of fingers, right? In this case, if you add all of these up, anybody do that already? 220, right? Okay, you need a total with these questions. You can't do it without a total. It'll be 220. And then in this case, chicken fingers, you sold 70 up. So the experiment, you have to base it on what actually happened, right? So let's turn this. We're not gonna simplify. I don't want to focus on simplifying today. So just go 70 divided by 220. I do want you to be able to write this as a decimal. So we write down 0 point, how many decimal places? I said 4, right? So 3182. Right? And then comma, we just multiply whatever we got on our calculator when we divide it, we just multiply it by 100. And so you get 31.82%. Okay? So those are, they're all saying the same thing, just in different formats. Okay? So make sure you have that written down. Some students ask me, do I need to have this? Not necessarily. You can just do the fraction or decimal, percent, whatever is. I'm going to go quite frequently. I'm just going to state it in 3 different ways so you know how to do it. Okay, that's the experimental probability. Now, this is the next question. What's the theoretical probability of someone buying chicken fingers? In theory. Oh, you're not supposed to see that. You didn't see it, right? Anyways, just write that down. What's the theoretical probability? I highlighted the theoretical part. You should probably underline or do something with it of someone buying chicken fingers. In theory, if you're just gonna, like, if somebody just goes on the stand and needs to pick one of them, in theory, there'd be 1 in 4 chances of someone picking chicken fingers. But there's a problem with that because you can't tell me what I'm gonna like or what I'm not gonna like. I might actually always go for chicken fingers, in which case it's 100% chance that I will go for chicken fingers. But if somebody randomly chooses one of those 4 menu items, then it would be 1 in 4 chance of someone doing that, and that's 25%. Okay, so you need to know the difference between the two. So they're not the same, and in this case, it doesn't matter how often or if you sold more. Let's say you sold to 1,000 people. This is probably going to continue to be the case, right? Like for this particular vendor at that particular location, people just might like chicken fingers more. It could be due to the price. It could be due to, that it's faster. You don't have to wait as long, even though that's probably not true. Hot dogs would probably be the best in terms of waiting time. But anyways, there are factors that are not present that also affect it, right? We don't know. So here we go. So this is just an example to show the difference between those two probabilities. Okay, let's continue. We don't need to write a whole lot down here except for just follow along. Okay, so let's zoom into that. A grocery store sells 3 brands of toothpaste. Okay, last month the store sold 75 tubes of brand A. Right, 75 tubes of brand A, 23 of brand B, and 57 of brand C. So they don't give you the total, but you're able to get it out of that. What's the probability? Right? The word probability is key because later on we're going to deal with odds. Okay, what's the probability of someone buying brand A? We're not going to simplify our fraction, right? We're not going to worry about that. We're just going to worry about coming up with the right numbers. Okay, so what kind of probability is this? If we were to state it right now the way it is, what kind of probability are we talking about? Experimental or theoretical? If we're going to base it on these numbers. The answer is experimental, right? It's not set, but we're going to insert that. This is actually the experimental. The book doesn't give you one or the other, but because we're basing it on purchases collected, it's almost like an experiment. It's almost like trial, like let's see what happens, right? And so probability of selling the brand A would be there's 75 tubes of brand A, and we need to have our total. Okay, let's do the total real quick here. That'd be 75 plus 23 plus 57. So we add up those 3 brands. Sorry, you can't see that. Put that on the side here. And if you add these 3 up, you get 155 tubes altogether. And that is what goes every time for probability. You just need to make sure the total goes underneath here. Okay, so 75 brand A out of 155 total. Let's state this as a decimal as well. Sure, you could reduce it, but so just divide them and then write down 4 decimals. 0.483. What's going to happen to that 8 here? It's going to turn into a 9 because of that, right? And that times 100 gives you 48.39%. You need to add the percent if you're multiplying it by 100, okay? So there are your 3 forms of stating your answer. Okay, now B, if the store sells 500 tubes of toothpaste. So we're talking a larger scale, right? On a larger scale, 500 tubes next month. That should also tell you that we're making a prediction. How many tubes can you expect to sell? And they have to be brand B, right? So this question would usually be worth 2 marks. Okay, so you're making a prediction. Write this down. Prediction of what? Like, oh, Well, we need the probability of brand B, and we're going to multiply that by the larger scale, larger sample. Okay, so I start with my formula so you can tell what I've done. Probability of brand B, you need to go up from and base it on what you know. Brand B, you sold 23 tubes of it. So you go 23 out of 155, and you multiply that by the larger scale. In this case, it's 500 tubes, right? And let's do it underneath. This is how I do it. 23 divided by 155. Oops, let's try that again. Right, 23 divided by 155. I put it over here. And then I just multiply it by, in this case, 500. So watch this. We're talking toothpaste, right? So this is 74. I want you to write down the decimal and you just go dot, dot, dot like that. But you know that you can't give me a decimal answer. So this has to be 74 tubes. Okay, 74 tubes approximately. You're expecting to sell 74 in a sample of 500. Okay. C? There is no C. Now there is. Okay, write this down. What is the theoretical probability? I'm just going to shorten it there. Probability of a customer selecting brand C. And this is randomly selecting, right? So somebody walks into Superstore, closes their eyes, and walks out with a tube, right? So we would say probability of brand C. That would be, how many choices do you have? 3. And only one of them is brand C. So it's just 1/3. Okay. And you should know this one. 1 divided by 3 is just 0.333 repeated, which would be 33.33% if you multiply that by 100. So we're not talking like a consumer. I hope that you as a consumer, you walk into the store and you look at price, you look at how much is in the tube, you look at how many dentists approve of it, even though that's most of the time, who knows, right? The #1 recommended brand, right? It's like, how do we know? But anyways, this is just randomly selecting, okay? Let's go to the next page. I'm going to walk you through that one example here, the blood type example, and then you're going to be on your own for a bit, okay? And tables are very important to me and to the province, so you will see quite often, you'll see a table like this, you need to decipher it, okay? The table shows the number of people of each blood type who donated blood at a recent drive. Make sure you read carefully, okay? So you have your blood type, you have the number of donors here. Because this is probability, there's a pretty good chance that you need to know your total. Okay, so I'm going to write down my total right here before I continue. So basically what you need to do is you need to add up all those numbers, and I get 850. I know it's hard to see, so make sure you can see that 850 there, okay? Just write it down, maybe a little bit underneath it or something. But you've got 850 total donors in this case. That's a pretty good sample size, okay? What's the probability? What's the probability? Very important, because can you just make sure you listen to this part? Down the road, you might see odds. What are the odds? That's different. It's going to be answered completely differently. So probability is a fraction, okay? That a person selected at random has to say that technically with the following blood type. So let's answer this as best as we can. So probability of someone having B positive, okay? We know that it's out of 850. And you just go ahead and look at B positive. It's right here. And we have 77 donors in that case. So that's the probability of someone having that blood type. Then we're going to go comma and write the decimal of it. That I need you to be able to do. 77 divided by 850. That is, watch carefully, 0.0906, right? Because next to the 5, there's an 8. That bumps it to a 6. Then you multiply that by 100, and you write down the percentage, and that's 9.06%. As soon as you multiply by 100, you need that percent symbol next to it. So almost 10% of the population in this sample, right, have B positive. Next. Okay. Probability of somebody having O type O, right? And we still have 850 that we're considering. And if you notice carefully here, this is important for you to understand. O, we have O positive and we have O negative. So if you combine these two, that is type O, right? Sorry, you can't see that there. So they're saying both of them combined, right? That's what this question is saying. So you need to be able to figure that out, right? So you go 327 plus 69 there. And let's just add that up. That's 396 over 850. And I'm going to, I know I can reduce that, but I'm not going to bother with it. I'm just going to go this divided by that. I'm going to divide the two and get 0.4659. Multiply that by 100. That is 46.59%. So close to half of the people, right? Close to half of the population would be type O, right? I don't know much about this, but is O positive compatible with O negative? You could get the blood from either one, yeah? Okay. So good. Next, AB negative. Probability of having AB negative. And so we are still out of 850. And if you look at that, AB negative, in this case, there's only one person. So extremely rare, right? So that'd be 1 out of 850. And this is where I actually wouldn't mind you trying, how would you write this as a decimal? Because it throws some students off, this one. Watch this. It's 0 point, and that's why I like you to have 4 decimals because of this, okay? Because otherwise you'd say 0, right? If it's 2 decimals, so it's 0, 0, 1, and then that 1 turns into a 2. That's how you would correctly state your decimal there. And then I multiply that by 100, and this is where students also, they think like that can't be, that's too small. I'll multiply by 100 again, right? And then they put down 11.76%. No, this is it. It's 0.12%. It's basically what it is. Question. I can't add that because there's no room. What's the probability of not having AB negative? The probability of not having AB negative. It would have to be 849 out of 850. Does that make sense? Right? Because only one has, so 849 out of 850 will not have. Or if you want to put it this way, go 100% minus 0.12, 99.88% of people would not have AB negative. So watch the wording very carefully. Okay, let's keep going here. And then you're gonna work on by yourselves a bit, okay? If data approximately represent the blood type distribution of the general population, they're saying if this, what we're observing here, is about correct, like if that's going to be the case in general, even if you look at all of Canada or all of Winnipeg, right, bigger population, then how many people in a group of 5,000 are likely to have AB positive? If you read this statement, you should recognize that you're making a prediction. Sorry. And you're making a prediction based on what you've observed, okay? So prediction is going to be probability of AB positive, right, times 5,000. That's my larger sample. Should we write this down? Okay. What's the probability of AB positive? I haven't done that yet, so I'm just going to go out of 850. Then I go up to my chart and see that there were 27 people on this smaller scale that had AB positive, and you multiply that answer by 5,000. I don't have room, so I'm going to go like that, right next to it. So we go 27 divided by 850. I hit equal on my calculator, and I do that because I want to save you trouble, okay? So then I multiply my answer by 5,000, and I get 158.82, and just go dot, 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 like that. And then you will say approximately 159 or 158. I don't care that much. I think you were taught, right? Like if this is a 5 or bigger, you bump up. So 159 people you would expect 159 to have that blood type. Okay. So here, I want you to pay attention to the ones I want you to try now. So circle them. Okay, I'm going to circle because I'm going to skip a few. I want you to try this one. So circle question 5 on 149, okay? And then backside, that C there is still based on that previous question, okay? Then we skip all of this. We go to page 151 and just start at the bottom. And I want you to write down do 1 to 6. Okay? Questions 1 to 6. So it goes over 2 pages. Okay. And look at my examples. I did charts like these with you. I can guarantee you that an AC that you will see tomorrow will have something like this on there. So take the time, work through all these questions so you're prepared. I will give you the answers, and I will talk a little bit about it tomorrow as well. but make sure you take the time to do so, okay? I think what I'm going to do is post the answers later on. I'm going to scan the answers and post it on Google Classroom so you can check.